Good evening, and welcome to the Blind Tinkerer's Workshop once again. I have here on the bench a schematic which I drew up of a high voltage tripler. And as you can see here is a high voltage transformer secondary. And we have an input capacitor. We have a diode charging up another capacitor. We have another diode charging up this capacitor. And at this point here, we take our voltage reading off of this. This is the voltage tripler using 3 capacitors. And we put the other lead over here. If you want to make a voltage quadrupler, you would just add this capacitor and diode over here. So I left it separated here so you can just bring it over to here. I want to make a voltage tripler rather than a voltage doubler. Voltage doubler would just eliminate all this. Okay, so I have here on the bench the 1200 volt, what I measured, about 1300 volts of the snapper, the bug snapper. And this is the first one that I scrapped and removed the capacitor. And actually I removed the diode for the LED, the LED diode. The transistor is still in there. And the transistors on these two pieces, I have the numbers written down here. I'm not sure which is which. I have to get my microscope out. But one of the transistors is a D like in dog 965. And then there's another number after it, S like in Sam 211. Okay, that's out of the first zapper. That's out of this one. This one, the one I've been demonstrating, uses a different number transistor, but physically they look identical. The number on this transistor here is a 8050SS, like in sugar. And then there's a D, and then there's a 331. Okay, so I didn't try looking these up. The books I have are fairly old, so I doubt they'd even be listed, and you probably have to look on the internet. But anyways, I have no idea what they are. But what I want to try to do is to make a voltage tripler. Now I can modify this one and make the voltage tripler for this. But this is going to be a little difficult because there's no holes in the board and I'd have to put them down from the back side or drill down, and I don't have drill bits that small, and I'm not going to deal with small printed circuit stuff. It's going to be really difficult. On this one, as you can probably see, and we'll get you on macro here, you can see there are holes. Now I know I stripped it down quite a bit, but there are holes there in the board. And of course I can go from the back. So it might be a little easier for this one to be modified rather than the other one. But this didn't seem to put out quite as much voltage as the other one. Alright, the problem's going to be the diodes, now I've been looking at YouTube videos, and the diodes on some of these circuits, they don't really tell you what diode to use, but a lot of them say to use 1N4007, which is 1000 PIV diode, I believe it is, 1 amp. Well, I think you're going to blow the diodes. I think the diodes should be rated at a higher voltage. So last year I bought 10,000 volt diodes off of eBay because I was going to make a 8,000 volt power supply using that bug whacker transformer, the one you plug into the wall that hangs outside, but I decided I'm not going to do that. And these diodes are very large compared to the diodes that are in here. Now, the diodes that are in here, when I measure with my digital meter, I'm reading approximately 1.6 volts instead of a half a volt, which a 1N4007 would read, anywhere from probably 0.4 to 0.5 or thereabouts. In other words, under a half a volt. These are reading about it, not these, but this diode. This is about the size of a 1N4007, but there's no numbers on it. It is not a 1N4007 because it's going to be working right at the 1000 volt limit of the diode. So it is a high voltage diode, but I don't know what it's rated at. But if I use 10,000 volt diodes, I should be safe, but they're awful big. Because my feeling is, and I've seen YouTube videos where they're putting together voltages that are going to be a lot higher than what I'm going to be using, and they're using 1N4007s. There's nothing really on YouTube, and I looked around because I'm not a theorist. You know, I know some theory, but I don't know a lot. Nothing's really mentioned, without going into probably formulas and stuff, that if you're inserting, you know, you're applying, let's say you're applying 1,000 volts here. Let's say this. Okay, we were not in camera, so let's get in camera here. All right. Make sure we're in camera. All right. All right. For instance, let me just make sure this paper's kind of folded a little. Let's say now you've got the output of this secondary of this high voltage transformer is putting out 1,000 volts AC. All right. We'll disregard the peak voltage at this time because that's going to be higher. As long as your diodes are rated for it and your capacitors are rated more than 1,000 volts, you're okay. All right, my way of thinking is a lot of these schematics, I've seen a few voltage doublers, triplers, quadruplers, and I've seen some on YouTube, and they're building these things with high voltage capacitors, which is fine, but they're using 1N, not all of them, but some of them are using 1N4007. Now, if I remember the specs on a 1N4007 diode, it's 1,000 peak inverse volts, PIV, at 1 ampere, okay? All right, my way of thinking, and I could be wrong because I've been wrong more times than I am correct. To simplification, okay, disregard the peak voltage, you know, okay? let's just simplify things here. Now, I like things simple. I don't like them complicated. So I want to explain simply. Disregard the peak voltage and the AC that's coming through the secondary of this transformer, which will not be a pure sine wave because the oscillator in these things here are certainly not sinusoidal. Okay. You're getting 1,000 volts here, for instance. That would mean that this capacitor here has to be rated at least for that and more to allow for the peak. As I said, we disregard it now. It also means this diode here must be rated at least 1,000 volts. So if this is the case, you're running the 1N4007 at its limit as far as voltage is concerned, not current. Those diodes are good for 1 amp, and we're not going to get 1 amp with this circuit. Okay? But the voltage, the PIV voltage, breakdown voltage, is going to be exceeded, or very close to it. Okay, now when the charge comes down here and charges this capacitor, okay, and then it's getting through this diode, okay? So now you've got more charge. You charge this capacitor, now you charge this one, so you've got double. I could be wrong. You've got double. So this diode here has to handle twice the voltage, DC, not AC, as this one. So now we're charging up here, now we're charging this one. Okay? So now this diode's got to be able to handle 3 times the current, the voltage, voltage. So nobody mentions that. I looked all over, and nobody's mentioning about what voltage rating should your diodes be if you want to make a voltage tripler, or you add this circuit here and just connect these here, and you add this, and you've got a voltage quadrupler. In other words, 4 times the voltage. Then this diode's got to handle 4 times this. That's my theory. It never was explained, and I've looked all over YouTube on this. I can't understand why some of these people that are experimenting and building these things are using 1,000 PIV diodes, in other words, 1,000 volt diodes. Why aren't they using something that's at least rated, in this case, maybe 5,000 volts, but I'm going to be using 10,000 volts. And we're not going to be getting started on any project on this. I'm just going to get some of this theory out of the way here. These I've got off of eBay. And I've got them in case I need them to put in an oscilloscope. They are 001s, 0.001, 15,000 volt ratings. So this is what I was going to use in that power supply that I was going to make. Now this is probably a little too good to put into a bug whacker. So I can understand you're using these capacitors here, all right, for the voltage tripler. That's fine. But why a 1N4007, which most of the experimenters seem to want to use? All right, it don't make sense to me. I have here on the piece of paper here a 1N4007. I have here on this first Harbor Freight bug zapper high voltage supply, the diode's still here. You can see that the size of this is about the same as a 1N4007. Now, to me, A 1N4007 is not a high voltage diode. It's good for a low voltage power supply. You want to run a power supply 500-600 volts DC. That's fine. But I would use something that's at least twice the rating of the maximum DC output, and definitely something twice the rating of the output of the transformer. So what I'm going to do here now, and then we're going to end this video, because I just want to get some wrinkles out of this project that I'm going to be doing before I do anything. So what I'm going to do now is I'm going to take my Fluke 73, set it on diode, and I'm going to show you the voltage drop across this diode versus the voltage drop across the 1N4007. I can't read this diode. If I see a number on it with my microscope, I'll put it on the video here. Alright, it's a little difficult here. I got the meter pretty close here. Alright, so you're going to have to, I can't do picture in picture as I said before. So, you're going to have to take my word for it when I say that the leads are on the diode. So, I'll try to hold them up, but it's going to be very, very difficult to do that. Alright, this is a 1N4007. It's 0.520. Okay, so this is the 1N4007. 0.522. Alright, so it's a half a volt drop. Okay. Now, let's see if I can get my meter in here. .575. In other words, over 1.5 volts drop. See the reader there? 1.570. So that tells me that this is a high voltage diode. The point of this video is you cannot use 1N4007 diodes for high voltage. I am sure somebody will say I am all wet behind the ears. Maybe I am. Once again, I'm the tinkerer. I don't claim to be a genius. Thanks for watching. And I haven't given up on this project by no means. We are working our gray matter, and we will have something. I'm in no hurry. This is not a priority. This is just more of an experimentation and building something. And it's more of a learning experience for me. Most of the stuff that I want to do or something, if I can buy it ready-made, I will do that. Certainly a lot easier and less aggravating. But it is fun to build some things like this. So stay tuned for more. I'm going to put this video up together tonight. It'll probably get up there tomorrow maybe.